June 15th, 1943. 25,000 feet above the English Channel, German ace Klaus Brenner squinted through the canopy of his Messerschmitt at the approaching American formation. 8 P-47s, those fat, lumbering, flying milk bottles the Luftwaffe had been swatting from the sky for months. Brenner smirked. The Thunderbolts climbed like overloaded freight trains, barely managing 1,500 feet per minute, while his Bf-109 could dance circles around them in a vertical fight. Another easy kill, he thought. But as Brenner pulled into his attack dive, something impossible happened. The lead P-47 didn't turn or dive away. It pitched up hard, into a climb so aggressive it defied everything Luftwaffe intelligence believed about American fighters. The massive machine clawed skyward at nearly 2,000 feet per minute, its engine screaming at full power, chasing Brenner into what had always been his domain. In the cramped cockpit of his Messerschmitt, the German ace felt a flicker of fear for the first time, as the stupid American propeller, 13 feet of revolutionary paddle blade engineering, turned the sky's biggest joke into its most terrifying predator. The morning reports from the European theater painted a grim picture that no amount of Pentagon optimism could disguise. By September 1943, the P-47 Thunderbolt had earned a reputation that made even veteran American pilots request transfers to anything else with wings. The Luftwaffe's mocking nickname, Jug, inspired by the plane's milk bottle silhouette, had crossed enemy lines and now echoed bitterly through Allied briefing rooms. At Wright Field, Colonel James Johnson flipped through the latest combat assessment reports, his coffee growing cold as the numbers told their harsh truth. The P-47's climb rate of 1,500 feet per minute made it easy prey for the Bf-109, which could ascend at more than 3,000 feet per minute. Over occupied France, German pilots had perfected a cruelly simple tactic: climb above the Thunderbolts and pick them off at leisure. The massive American fighter, over 7 tons fully loaded, simply couldn't follow into the vertical realm where modern air combat was decided. At Hamilton Standard Division, engineer Frank Caldwell studied the same reports from his cramped office. But where military leaders saw failure, Caldwell saw physics. The P-47's Pratt & Whitney R2800 double Wasp engine produced 2,300 horsepower, more raw power than any other fighter engine in the world. Yet much of that power was being wasted. The problem wasn't the engine or even the airframe. It was the narrow-bladed propeller, unable to absorb and convert that immense torque into thrust. Propeller design hadn't changed much since the Great War. Thin, knife-like blades were efficient for cruising, but useless when combat demanded brute power. The P-47's standard 11-foot propeller simply couldn't handle the R-2800's full output. At maximum throttle, the blade tips approached supersonic speeds, forming shockwaves that destroyed lift and turned the propeller into a wildly expensive air brake. Caldwell's solution broke every rule of conventional propeller design. Instead of thin, elegant blades, he envisioned thick, paddle-shaped ones, broad surfaces capable of grabbing huge masses of air and hurling them backward with raw force. It looked more like a boat propeller than an aircraft's, clumsy perhaps, but brutally effective. At Hamilton Standard, his colleagues listened with polite skepticism. Tom Richards, the division's senior aerodynamicist, pointed out the obvious downsides: increased weight, greater drag at cruising speed, and manufacturing challenges that could cripple production. The military had already invested millions in the existing tooling. Retooling everything for an unproven design would be enormously costly and delay deliveries. But Caldwell had done the math. A 13-foot paddle blade propeller could fully absorb the R-2800's output. The extra thrust would offset drag, and the larger diameter would keep tip speeds below the shockwave threshold. Most importantly, it would give the P-47 the climb rate it desperately needed to challenge German fighters on equal terms. Not everyone agreed. At Curtiss Electric, Hamilton's rival in military propeller contracts, senior engineer Robert Hayes dismissed the paddle blade idea as a desperate fix for a doomed aircraft. Curtiss was pursuing its own improved narrow blade design, slightly larger in diameter with better pitch control. Conservative, safe and compatible with existing production lines, the U.S. Army Air Forces found themselves torn between two philosophies, one offering modest, low-risk improvement, the other promising a radical leap forward at enormous technical and financial risk. Colonel Johnson, tasked with choosing between them, knew his decision would shape the fate of thousands of American pilots flying into combat over Europe. Meanwhile, across the Atlantic, Luftwaffe intelligence officers were already tracking American aircraft developments with characteristic German thoroughness. Major Wilhelm, stationed at a Luftwaffe technical evaluation center in occupied France, had personally examined several captured P-47s. His reports to Berlin were dismissive. The American fighter, he wrote, was a brute force design that relied on heavy armor and raw engine power to make up for poor aerodynamics. German pilots could exploit its sluggish climb rate and limited maneuverability indefinitely. This confidence was shared throughout the Luftwaffe command structure. The Americans, while clearly capable of producing aircraft in vast quantities, still appeared unable to match German engineering sophistication. To the German High Command, the P-47 embodied everything wrong with American design philosophy: big, heavy, crude, and inefficient. Luftwaffe pilots joked that shooting down a Thunderbolt was like hunting a flying refrigerator, hard to miss and guaranteed to fall once hit. Back in the United States, the September test flights at Wright Field would determine which engineering philosophy would shape America's air power for the coming battles. Frank Caldwell's experimental paddle blade propeller had been mounted on a single P-47D for evaluation. On the ramp, the aircraft looked almost absurd, its massive blades resembling something built for a transport plane rather than a fighter. Test pilot Captain Robert Anderson climbed into the cockpit with orders to push the new configuration to its limits and report any performance changes. As Anderson taxied out for takeoff, neither he nor the engineers watching from the control tower could have imagined they were about to witness the rebirth of what had been aerial warfare's greatest disappointment, soon to become its most feared predator. The conventional wisdom that had defined fighter design for 2 decades was about to be shattered by 13 feet of revolutionary engineering that would rewrite the rules of air combat over Europe. The first test flight on October 12th lasted just 14 minutes before Anderson brought the modified P-47 back to Wright Field, reporting severe vibrations. The enormous paddle blades had created harmonic oscillations throughout the airframe, threatening to shake the aircraft apart above 70% throttle. From the control tower, Caldwell watched grimly as ground crews swarmed the fighter, checking for stress fractures and loose rivets. The vibration issue wasn't entirely unexpected. Propeller harmonics had plagued aviation since the Wright brothers, but the intensity here suggested deeper structural flaws in the blade design. Caldwell's team spent the next 3 weeks reworking the blade route, attachment system, and rebalancing the propeller hub. The original blades had been built using standard manufacturing techniques that worked well for narrow designs, but proved inadequate for the immense forces generated by the paddle configuration. Each blade weighed nearly twice as much as its conventional counterpart, producing rotational stresses the standard hub simply couldn't withstand. The fix required custom-forged blade shanks and an entirely new hub assembly, adding roughly 200 pounds to the aircraft's nose. The second test flight on November 5th brought different but equally frustrating results. The vibration problem was solved, but the performance gains fell far short of Caldwell's expectations. Instead of the projected climb rate of 1,900 feet per minute, Anderson recorded barely 1,600, only 100 feet per minute better than the original propeller. Top speed gains were equally underwhelming, 410 mph versus the baseline 400. At Curtis Electric, Robert Hayes received the disappointing data with quiet satisfaction. His team's improved narrow blade design had completed its own trials just days earlier, showing far better results, a climb rate of 1,650 feet per minute and a maintained top speed, all without the added weight or complexity of Caldwell's radical setup. Hayes promptly forwarded his findings to Colonel Johnson, attaching a memo suggesting that Hamilton's Standard's bold experiment had proven itself an expensive dead end. But Caldwell wasn't convinced. He believed the issue lay not in the paddle blade concept itself, but in the propeller's pitch calibration. The design had been based on theoretical calculations, assuming perfect test conditions. Real-world data showed that the optimal blade angle for climb performance differed significantly from the setting that achieved maximum level flight speed. The P-47's constant speed propeller system could automatically adjust pitch, but its range had been designed for narrow blades, not the new paddle type, working 18-hour days in the Hamilton Standard Engineering Lab. Caldwell's team developed a new constant speed mechanism with double the pitch adjustment range of any existing system. The upgrade required major modifications to the propeller governor and hydraulic controls, but it would finally allow the paddle blades to operate at peak efficiency throughout the entire flight envelope. The system could now shift from a coarse pitch for high-speed cruise to an extremely fine pitch for maximum static thrust during takeoff and climb. The challenges, however, extended beyond pitch control. The paddle blade's increased surface area created new cooling problems for the massive R2800 engine. The larger propeller disc pulled far more air through the cowling, but at slower velocities due to the added resistance. As a result, engine temperatures began climbing dangerously high during extended full-power operations, threatening to damage the R2800's cylinders. Caldwell's team was forced to redesign the cowling's air intake system and add additional cooling louvers to stabilize engine temperatures. Meanwhile, Lieutenant Colonel Johnson faced mounting pressure from Pentagon officials who questioned whether the P-47 program still justified its escalating costs. The new Boeing P-51 Mustang was showing extraordinary promise in early trials, outperforming both the standard P-47 and the experimental paddle blade variant. Many argued that resources should be diverted toward ramping up Mustang production rather than salvaging what they viewed as the Thunderbolt's fundamentally flawed design. The third test flight on December 8th finally revealed the paddle blade propeller's true potential. With the new pitch control system and cooling improvements installed, Captain Anderson put the modified Thunderbolt through a demanding series of combat maneuvers once considered impossible for the aircraft. The P-47 climbed to 20,000 feet in just 10 minutes and 40 seconds, a sustained rate of 1,850 feet per minute that nearly matched the best German fighters. Even more impressively, the Thunderbolt achieved this while carrying full combat weight, armor, fuel, and ammunition included. Speed trials were equally encouraging. At 25,000 feet, the upgraded P-47 reached 445 mph in level flight, a 45 mph gain over the standard configuration. The increase wasn't due to reduced drag, but rather the propeller's vastly improved efficiency in converting engine power into thrust. At high altitudes, where the air thinned, the paddle blade's greater surface area provided superior grip, delivering performance no conventional propeller could match. But the most astonishing results emerged during dive recovery tests. The P-47 had long been infamous for its difficulty pulling out of steep dives. Its standard propeller failed to generate enough reverse thrust to counter its immense momentum. With the paddle blade propeller, however, Anderson discovered that the new fine pitch setting provided significant braking force, allowing the aircraft to decelerate and recover from dives that would have been fatal with the original setup. In Germany, late December intelligence reports dismissed these developments as little more than American desperation. Luftwaffe analysts noted that US engineers were experimenting with oversized propellers, but saw the modifications as futile attempts to rescue an outdated design. Major Specht's assessment concluded that even with such improvements, the P-47 remained inferior to German fighters in every category except straight-line speed and dive performance. The December data, however, was enough to convince Colonel Johnson to authorize limited production of the paddle blade propeller for operational testing. Hamilton Standard was awarded a contract to produce 50 units for installation on P-47 D-22 models bound for Europe in early 1944. The order was a major gamble. If the design failed in combat, American pilots would pay the ultimate price. Caldwell's engineers worked tirelessly through the Christmas holidays, preparing production, tooling, and training factory personnel on the complex new assembly procedures. Each paddle blade propeller required roughly 40% more manufacturing time than standard models and cost nearly twice as much to build. The financial risk was enormous, but the potential reward, transforming the P-47 from an underperformer into a top-tier fighter, made it worth pursuing. As 1944 began, the first production paddle blade units rolled out of Hamilton Standard's factory, bound for modification centers where they would be fitted to Thunderbolts headed to the European theater. Neither the American engineers who built them nor the German pilots who would soon face them could have imagined how dramatically 13 feet of reimagined aluminum and steel would alter the balance of air. Power over Europe, the first paddle blade equipped P-47s arrived at RAF Boxstead on March 15, 1944, sparking immediate controversy among the veteran pilots of the 356th Fighter Group. Captain Mike Gladish, a Polish exile with 12 confirmed kills, inspected the massive new propeller with open skepticism. The blades looked crude and oversized compared to the sleek, narrow props he trusted his life to. Several pilots mockingly dubbed the modified aircraft barn door specials and requested permission to keep flying their standard Thunderbolts until the new version proved itself in combat. Group Commander Colonel Harold Ralph faced a difficult dilemma. His men had survived months of fierce aerial combat thanks to skill and an intimate understanding of their machines. Forcing them into untested aircraft could be disastrous. Yet orders from the 8th Air Force headquarters were unambiguous. The modified P-47s were to be evaluated under real combat conditions as soon as possible. The success or failure of Caldwell's paddle blade design would be decided not in test flights or engineering reports, but in life-and-death battles against battle-hardened Luftwaffe pilots over occupied Europe. The first combat mission for the modified Thunderbolts was launched on March 22nd, a bomber escort operation to Berlin. Gladish led a flight of 4 paddle blade P-47s as high cover for a formation of B-17 flying fortresses approaching the German capital. At 30,000 feet, well above the bombers, Captain Gladish spotted a formation of Messerschmitt 109s diving from 35,000 feet in a classic bounce attack. Under normal circumstances, the P-47s would have been forced to dive away, relying on their superior speed in descent to escape the Messerschmitt's climbing advantage. Instead, Gladish pulled his flight into a steep climb to intercept the attackers head-on. The new paddle blade propellers clawed through the thin air with unprecedented authority, maintaining a climb rate of more than 700 feet per minute, even at 30,000 feet. Performance that standard propellers could barely achieve at half that altitude. The German pilots, expecting the Americans to dive for safety, were stunned to see P-47s climbing directly into their attack path with enough energy to fight in the vertical plane. The entire engagement lasted less than 3 minutes, but it shattered long-standing German assumptions about American fighter capability. Gladish's wingman, Lieutenant Robert Johnson, managed to stay locked on a Bf-109 through a series of climbing turns that would have been physically impossible with the standard propeller. The German pilot, Major Hans Dürmann, later reported to Luftwaffe intelligence that the American aircraft displayed climb performance equal to that of their own fighters, a claim initially dismissed as the result of combat stress or misjudgment. Word of the encounter spread rapidly across Luftwaffe fighter units throughout Western Europe. For years, German pilots had relied on the certainty that they could outclimb any American aircraft, dictating the terms of engagement from superior altitude. The possibility that the P-47 could now compete in vertical maneuvering threatened to upend their entire tactical doctrine. Several group commanders immediately demanded confirmation from intelligence sources. Major Wilhelm, Specht's technical intelligence unit, finally obtained a paddle blade-equipped P-47 on April 2nd. When Lieutenant Charles Morrison crash-landed near Calais after his aircraft was damaged by flak during a ground attack mission. Although Morrison destroyed most of his sensitive equipment before capture, the propeller survived intact for German analysis. Specht's initial report dismissed the blades as oversized and inefficient, predicting they would create more aerodynamic problems than they solved. However, a detailed technical inspection quickly overturned that assumption. German engineers found that the paddle blades used advanced alloys and manufacturing precision far beyond anything currently in Luftwaffe production. The constant speed mechanism revealed innovations in hydraulic control systems that German designers had not yet mastered. Most alarming of all was the realization that the Americans had solved propeller efficiency issues the Germans had long considered unsolvable within existing design limits. By late April and early May, frontline reports painted an increasingly grim picture for Luftwaffe operations in the West. American P-47s were engaging German fighters in vertical combat and winning. The 356th Fighter Group alone claimed 21 enemy aircraft destroyed during April, most from engagements where standard Thunderbolts would never have survived. German pilot casualties mounted as their altitude advantage. The foundation of Luftwaffe air tactics began to vanish. The consequences went far beyond individual dogfights. German controllers had always positioned interceptors above the bomber streams, confident the P-47s could not climb fast enough to interfere with the initial bounce. But the new paddle blade-equipped Thunderbolts could now maintain formation at bomber altitude and respond instantly to diving attacks from any direction. Luftwaffe interception missions that once relied on surprise from above were now facing American escorts at full combat readiness. By mid-May, nearly every operational P-47 in the European theater had been retrofitted with paddle blade propellers. The production program, once bogged down by tooling delays, was now turning out over 200 units per month. Hamilton Standard's factory in Connecticut worked around the clock, with Caldwell's engineers collaborating directly with production crews to streamline processes and eliminate defects. The results were undeniable. By month's end, combat statistics showed a 40% increase in air-to-air victory rates for units equipped with the new propellers compared to earlier configurations. Even more importantly, P-47 loss rates had dropped by 30%, as pilots could now climb out of danger instead of relying solely on dives to escape pursuit. The Thunderbolt was no longer the Luftwaffe's easiest prey. By late May, Colonel Johnson received authorization to expand the paddle blade program to all P-47 variants in production. What had once been mocked as Caldwell's stupid propeller trick had, against all odds, transformed the Thunderbolt into one of the most formidable fighters over occupied Europe, represented one of the war's most significant technological breakthroughs. Orders were immediately issued to retrofit existing P-47s in the Pacific Theater and to ensure all new aircraft rolled off the line with paddle blade propellers installed at the factory. German intelligence officers struggled to explain the sudden leap in American fighter performance to Luftwaffe commanders, who had long grown accustomed to maintaining tactical superiority over Allied fighters. Major Specht's updated reports reluctantly acknowledged that the Americans had gained a decisive technological advantage. Yet German aircraft designers lacked both the industrial capacity and critical materials to replicate the innovation. The Luftwaffe would now face the remainder of the war, knowing their fighters could no longer dominate the Americans through superior climb or altitude control. The transformation was complete. Frank Caldwell's paddle-blade propeller had turned the P-47 Thunderbolt from the Luftwaffe's favorite target into its most dangerous adversary, rewriting the balance of air combat over Europe just months before the D-Day invasion, when total Allied air supremacy would become an absolute necessity. Dawn, on June 6, 1944, brought the ultimate test of Caldwell's engineering revolution. Nearly 400 paddle-blade-equipped P-47s thundered across the English Channel as part of the vast armada tasked with securing the skies above the Normandy beaches. It was the largest deployment of modified Thunderbolts in history, their wide, gleaming propeller blades catching the first light of what would become the longest day in aviation history. Colonel Francis Gabreski led the 56th Fighter Group's sweep over Omaha Beach at 0630 hours. His 16 P-47s climbing to 25,000 feet with an ease that would have been unimaginable only months earlier. Below them, the greatest seaborne invasion in human history unfolded as Allied landing craft surged toward the fortified French coast. Above the once dominant, German fighters were conspicuously absent from skies they had previously controlled with impunity. The Luftwaffe's response revealed just how devastating Caldwell's paddle-blade innovation had been to German tactical doctrine. Oberst Adolf Galland, commanding the Reich's fighter forces, was forced to abandon the altitude advantage strategy that had guided German air combat since the Battle of Britain. His pilots could no longer rely on climbing superiority to strike Allied bombers from above. Instead, they were forced into low-altitude fights, where the Thunderbolt's heavy armament and rugged construction gave it the edge. Major Klaus Matuschka's Jagdgeschwader received orders to intercept Allied fighter bombers attacking German positions near Caen. But the tactical equation had changed dramatically since the new propellers appeared over Europe. Matuschka's Focke-Wulf 1-90s, once able to climb above American formations to dictate combat terms, now found themselves equaled or surpassed by Thunderbolts that could sustain high-performance climbs at any altitude. The first major air battle of the day erupted over the invasion beaches when 24 Messerschmitt 109s attempted to dive on. Allied naval forces supporting the landings, Captain Robert Johnson's flight of 8 paddle-blade P-47s intercepted them at 18,000 feet, having climbed from sea level in under 9 minutes, a rate of ascent that allowed interception before the Germans could even complete their attack runs on the ships below. The engagement showcased how thoroughly the paddle-blade had transformed the dynamics of air warfare. German pilots, who once fought by climbing above their opponents, now found themselves unable to escape American fighters that matched their climb rate and exceeded their level flight speed. Lieutenant Hans Wick, flying his 43rd combat mission, later reported that the American Thunderbolts climbed like rockets, maintaining pursuit through maneuvers that would have shaken off earlier P-47s. By midday, Luftwaffe controllers were reporting American fighter activity at altitudes once considered unreachable. Thunderbolts were now engaging German aircraft at 30,000 feet and winning dogfights through superior energy retention rather than brute force dives. The paddle-blade propellers allowed U.S. pilots to trade altitude for speed and then regain altitude quickly, enough to maintain initiative throughout extended engagements. The day's operational statistics told the story of Caldwell's triumph in unambiguous terms. Allied air forces flew over 14,000 sorties on June 6th, while the Luftwaffe managed fewer than 300, a disparity that reflected not only numerical strength but also the tactical supremacy established by the paddle blade-equipped fighters. Those German pilots who did engage found themselves consistently outclimbed, outturned, and outmaneuvered by American aircraft whose performance had rendered traditional Luftwaffe tactics obsolete. By evening, General der Jagdflieger Adolf Galland's situation report to Reichsmarschall Hermann Göring painted a grim picture of German impotence over the invasion zone. Galland's squadrons had claimed only 17 Allied aircraft destroyed during the day's operations, but German losses exceeded 40 fighters, an exchange rate that would rapidly cripple the Luftwaffe as an effective fighting force. The paddle-blade P-47s had proven themselves superior in every form of aerial combat, from low-altitude dogfights to high-altitude interceptions. The final engagements of the evening came as German night fighters attempted to strike Allied naval forces under the cover of darkness. Several squadrons of the 8th Air Force had been equipped with experimental radar systems for night interception missions, and the paddle blade propellers proved crucial for maintaining formation during complex nocturnal maneuvers. The Thunderbolt's enhanced climb rate allowed American pilots to seize altitude over German night fighters and attack with the very advantage the Luftwaffe had once relied upon. Frank Caldwell received the first reports of the D-Day operations at Hamilton Standard's Connecticut factory, where his team worked tirelessly to meet the military's insatiable demand for paddle-blade propellers. The stunning success over Normandy validated everything Caldwell had envisioned when he first proposed his revolutionary design. What had begun as a stupid propeller trick, as skeptics called it, had transformed American air power from a reactive defensive shield into an offensive weapon that ruled the skies of Europe. The larger implications of the paddle blade's success extended far beyond individual air battles. Allied air dominance over the invasion. Beaches allowed ground forces to advance inland without the devastating interference of German air attacks that had plagued earlier amphibious campaigns. The Luftwaffe's failure to effectively contest Allied air operations condemned German ground forces to fight the remainder of the war without meaningful air cover, a decisive factor in the outcome of the Western campaign. German engineers examining captured paddle-blade propellers in late June reached sobering conclusions about American industrial superiority. The modifications represented leaps in metallurgy, machining precision, and aerodynamic efficiency that Germany's resource-starved industry could not hope to replicate. More alarming still was the discovery that American engineers had solved the fundamental problem of converting high engine horsepower into usable thrust, an innovation that promised long-term dominance in aircraft design. As June came to a close and Allied forces consolidated their positions in Normandy, the full strategic weight of Caldwell's engineering revolution became clear. The paddle-blade propeller had not merely enhanced the P-47's performance, it had redefined the balance of air power across Europe. German pilots, who had once hunted Thunderbolts with confidence, now found themselves the hunted, unable to escape aircraft that could climb faster, fly higher, and fight harder than any they possessed. The transformation was total and irreversible. The fighter, once derided as a flying milk bottle, had become the scourge of the European skies, and the quiet engineer who had designed 13 feet of revolutionary aluminum and steel had, in doing so, changed the trajectory of the air war itself. The Luftwaffe would never again enjoy the tactical dominance that had once made its pilots the masters of Europe's airspace. When the war ended on May 8, 1945, Frank Caldwell sat in his Hamilton Standard office reviewing production figures that told the story of his achievement in stark precision. More than 12,000 paddle-blade propellers had rolled off American assembly lines since that first experimental model in October 1943. Each one was a triumph of industrial adaptation, factories retooled, workers retrained, and skeptics silenced by results. Colonel Francis Gabreski's final mission report from the European theatre added the human measure behind those statistics. His 56th Fighter Group had flown over 15,000 sorties with paddle blade-equipped P-47s, claiming 438 enemy aircraft, destroyed for the loss of only 47 in air-to-air combat, a staggering 9.1 exchange ratio that would have been unthinkable without the propeller's enhanced climb and altitude performance. The statistical transformation of the P-47's combat record told the story more powerfully than words. Before the paddle blade, Thunderbolt units achieved roughly a 3.1 exchange rate, impressive but not decisive in a war of attrition. After Caldwell's innovation, that figure tripled, turning each engagement into a one-sided contest and accelerating the collapse of German air power over Europe. Major Wilhelm Specht's final intelligence report, discovered in captured Luftwaffe archives after Germany's surrender, acknowledged with reluctant clarity that the Americans had achieved a technological breakthrough of decisive military consequence. German engineers had attempted to design similar propeller systems for their own fighters, but chronic shortages of materials and industrial capacity ensured they would never catch up, made meaningful progress impossible. The paddle blade propeller thus remained an exclusively American advantage throughout the final year of the war. The human cost of that advantage was measured not in losses, but in the lives it saved. Pilots who came home instead of joining the growing casualty lists of the war's earlier years. Lieutenant Robert Johnson, who achieved his first aerial victory in a paddle blade P-47 over Berlin in March 1944, completed his final combat mission with 28 confirmed kills and not a single defeat at the hands of enemy fighters. His survival, multiplied across hundreds of airmen, stood as the truest testament to Caldwell's engineering triumph. Yet the paddle blade's influence extended beyond individual heroics, reshaping the very strategy of the air war. By early 1945, German bomber production had collapsed, not because every factory lay in ruins, but because the Luftwaffe could no longer field fighter escorts capable of protecting its bombers from relentless American pursuit. The paddle blade-equipped Thunderbolts made air operations so costly that the Reich's aviation industry abandoned bomber construction altogether, diverting precious resources into the desperate development of defensive interceptors. What began as Caldwell's unorthodox idea had sparked a technological revolution that redefined American aviation itself. The North American P-51 Mustang soon adopted paddle blade technology in its final wartime variants, as did the Republic P-47N, entering production just as the conflict ended. American designers had discovered a powerful truth that brute force engineering could succeed when paired with advanced materials and industrial precision. Frank Caldwell's personal recognition came quietly but meaningfully. A Presidential Medal for Merit, presented by Harry S. Truman in a White House ceremony on June 15, 1945, the citation commended his revolutionary propeller design that materially contributed to Allied air superiority over Europe. But Caldwell knew the true victory belonged to the countless American pilots who had flown his propellers into combat and lived to return home. Post-war intelligence analysis of German aircraft programs revealed how completely the paddle blade had derailed enemy plans. Captured documents showed that by late 1944, German engineers had abandoned several advanced fighter designs because they could not match the climb performance that American aircraft now routinely demonstrated. The psychological shock of facing Thunderbolts that could outclimb the vaunted Messerschmitts proved as devastating as the tactical disadvantage itself. The manufacturing legacy of Caldwell's program extended well beyond military aviation. In developing the paddle blade, American factories had mastered precision forging, casting, and machining techniques that would power the next generation of U.S. industry. The metallurgical breakthroughs that made the propeller both strong and lightweight soon improved automobile engines, heavy machinery, and ultimately commercial aircraft. Caldwell's wartime innovation had accelerated American industrial progress by years. The strategic lessons of the paddle blade were not lost on post-war planners. The program proved that decisive technological superiority could emerge not only from radical new inventions, but from bold reinterpretations of existing technology. American aircraft engines had long been powerful. Caldwell had simply found a way to harness that power more effectively than anyone thought possible. By the close of summer, assembly lines that once produced paddle blade propellers were being retooled for the booming civilian aviation market. The same broad blade principles that had given the P-47 its remarkable climb rate were now being applied to transport planes and airliners. Caldwell's wartime breakthrough was evolving into peacetime prosperity, promising to revolutionize civilian flight just as it had redefined aerial warfare. The final and perhaps most telling validation of the paddle blade's success came from the enemy itself. In post-war interviews, captured Luftwaffe pilots consistently identified the arrival of modified American fighters as the turning point when German air superiority became impossible to sustain. Major Klaus Matuschka, a veteran of over 200 sorties, described the paddle blade Thunderbolt as the aircraft that ended our war in the air. Frank Caldwell closed his final wartime engineering report with typical understatement, noting simply that the paddle blade propeller had exceeded all operational expectations. Behind those reserved words lay the full magnitude of an engineering revolution, one that had transformed American air power from a defensive necessity into overwhelming dominance. The stupid propeller trick, once dismissed as an impractical curiosity, had proven that the boldest, most unconventional ideas can yield the most decisive results. The war was over, but Caldwell's revolution in propeller design would continue shaping the future of aviation for generations. The principles he had demonstrated, that effectiveness outweighs elegance and that innovation often defies convention, would endure as the lasting legacy of the engineer who gave the Thunderbolt its wings. Deserved constant questioning, and that bold, unconventional solutions often triumphed where cautious refinements failed, would continue to shape American aerospace progress throughout the jet age and well into the future. 13 feet of paddle-shaped steel had altered far more than the capabilities of one fighter plane. It had proven the transformative force of engineering daring when confronted with seemingly insurmountable obstacles.